Hey you guys, we are back at it today. Hope you guys had a good day yesterday. I wanted to do like a little warm-up today to start with the rectangle to show you. Now, please note that I have to tell you that this is a rectangle. You cannot assume that it is a rectangle, even though it looks like one, because, sometimes it could just be a parallelogram. But anyways, this is a rectangle, because I say it is. And I just wanted to show you that with only one angle measure, we could find all of the rest of them. And the big reason why is because of those isosceles triangles we talked about. So I'm going to remind you, the way that we find the isosceles triangles is because all of the diagonals are congruent and they bisect each other. So this is the midpoint. And so therefore all of the diagonals and the little pieces or the halves of the diagonals are congruent. And then y'all remember how I taught you isosceles triangles? I suggested we draw arrows to help us. So that means, if I can get my pink, that this angle down here is also 30 degrees. Is that clear? Okay, now, I hope you can see this, but there's some symmetry here. So if you notice, this triangle down here is the same as this triangle up here. To me, it kind of looks like an envelope. But it's like if you reflected it over the x-axis, if you thought about it that way, you can kind of tell that they're congruent. So then you could put, let me go back to my pen, and you could put 30 here and 30 here. Now there's another way you could identify that. Another way you could identify that is because of alternate interior angles. Remember how we've done that before? So then you see the Z makes this angle congruent to this angle, and then I could do it with a different color and say, here, here, and here, so then this angle is congruent to that angle. All right, so I'm just showing you two different ways you could kind of visualize that. All right, nonetheless, we have 30. Okay, so then that's all the 30s that we have. Then we can find, let's get a different color, and then we know something about all the corners. We know that they are all 90 degrees. Okay, so if we know this angle, any of these angles are 30, we should be able to find the other one that makes the 90 degrees, and so that would be 60. So does that make sense? The way I got that angle is I just did 90 minus 30. Okay, and then I can basically go all the way around and do the same thing at all these other spots. Okay, and so then all we're left with are these four angles in here. So this one, this one, this one, and this one. Okay, so the way that we're going to find those is we're just going to use triangles, honestly. Okay, so we're going to use like this triangle right here. And so the way that we're going to do that is we're just going to take, since we know two of the angles, we can find the third one. I need to switch to get a different color. Okay, so we're going to do 30 plus 30, that's 60. And then, so that means we've used up 60 degrees, and then we're going to do 180 minus 60, which will give me 120. Okay, and so then I can see my highlighted yellow triangle. 120 plus 30 plus 30 is 180. Okay, then I know by vertical angles, you remember that vocabulary, that this one is also 120 degrees. Okay, and then I could do the same thing with the other triangle. So I'm going to show you two different ways you could do it. So you could do this triangle exactly the same way and just use the 60 and the 60 here. That would give you 120. So then that means this one would be 62. It's actually a 60 also. That's actually an equilateral triangle. But that's okay. Another way to look at this is, if you look at, I'm trying to get a different color here. Do y'all remember how we talked about linear pair yesterday? Ooh, sorry, that's not straight. Ooh, help me out. This 120 and this 60 should make a linear pair because it's a straight line, and so they should equal 180. Okay, and so then we can go back, and because that one is 60 by vertical angles, so is this one. So these two are congruent to those two. Okay, so if y'all notice what we just did, we literally, I gave you one angle. I think I gave you this 30 down here. I think that's where it was originally. With one angle, I could find all of the rest. Okay, so if you kind of use those rules with rectangle, it'll also help you with square. And yeah, so hopefully that's just a recap of rectangle. Now we're gonna kind of get back into the notes from yesterday. So this is exactly the same. Sorry, I'm trying to just zoom out a little bit. These are exactly the same notes as yesterday. We just only simply did rectangle because Henry woke up from his nap. So y'all got a little lucky. The lesson was a little short. Today we're going to do rhombi and squares. So we're going to do 2 shapes, but I think we can handle both of those because square is probably the easiest one. All right, rhombus is not really the most common one. I was just doing a puzzle with Henry, and they have on their puzzle, like it was a shape puzzle, and it was called a diamond. So you may be a little more familiar with just the term diamond, but a rhombus is like the technical term. Okay, so again, it has all the characteristics of a parallelogram. So all those things that we talked about 2 days ago, those still hold true. Diagonals bisect each other, opposite angles are congruent, consecutive angles are supplementary, and I can't remember the fourth one. I just went blank, sort of. So it's still a parallelogram, and now we have 4 congruent sides. Okay, so if you notice right here, I've already drawn a picture. You got 1, 2, 3, 4 congruent sides, and then the diagonals are perpendicular. I want y'all to write kind of out beside, as you'll write this down, 90 degrees. So that means when I draw in the diagonals, I can put a right angle here, which I really could put them anywhere, you know, but I'm just going to put it in one spot. Okay, so that's really special to the rhombus, which we hadn't seen yet. And then this last thing, it says each diagonal bisects a pair of opposite angles. Okay, so it bisects, but it doesn't bisect. We already know based on parallelogram that they bisect each other. So like this one's congruent to this one, and then this one's congruent to this one. But what this is saying is now it's bisecting an angle. So this angle up here is congruent to this angle, and then this one is congruent to that one. Now the reason I know all 4 of those are the same is because of alternate interior. So this one over here is going to be the same as this one, and then this one over here is going to be the same as this one. And then we know that this one will be congruent to this one, and then this angle will be congruent to that one. Okay, so I hope that helps a little bit kind of understand all of these 4. Pause it if you need to. Make sure you get all of that written down. All right. Okay, now we're going to use an example to solve some problems. So I think one of the things I was noticing, if you messed up or made some careless mistakes on your homework, it was just simply because maybe you didn't know what angle I was talking about or referencing. So make sure that you kind of follow it along. Try to draw the picture as best you can, and kind of outline like I'm doing. All right, so the number 1 question says B to C to E. So that's this angle right here. Now that 12 is talking about the side, so not the angle itself. Well, the first thing I'm always going to do with a rhombus is I'm going to put this in. I can put 1. I'm going to put all 4 so I don't forget. So that angle here is 90 degrees. So if I redraw this triangle, I have 90 degrees, I have 59 degrees, and so I'm looking for this angle right here, and I can find that pretty easily because of knowing 2 angles. So I'm just going to take my calculator, I'm going to add 90 plus 59, I get 149, and then I'm going to subtract that from 180, and so then I'm left with 31 degrees. Okay, does that make sense? Hope so. All right. Now it's asking us, I'm going to erase so I don't get this picture too jumbled here. I'm going to put the right angles back so I don't forget. All right, now it's asking me for B to E to C. Well, I just drew that in, so that is 90 degrees. Okay. Now it's asking us for A to C, this length here. Well, we know that the diagonals bisect each other because it is a parallelogram. So if E to C is 12, then so is A to E. And so A to C is 12 plus 12, which is 24 units. Not degrees because we're not finding an angle. Okay. And then the measure of A to B to D. So that's this angle here. Well, if we remember our properties from a moment ago, I said that this diagonal BD bisects this angle. So this one is the same as that one. And I just made it very thick and went over it so I can't see it. Let me do that again. So A to B to D, this angle, is the same as this angle over here, C to B to D. All right, so 59 degrees. And then lastly, it asks for A to D, which is this side length over here. And we said that all the sides are congruent, and so because I know it's 14 for one side, all sides would be 14. All right, so rhombus, I'm trying to get it all in one view. All right, so there's kind of the big things that we learned. I would say the two biggest are the last two. Most students will remember the second property, but the last two properties about the perpendicular diagonals and the angle bisectors, that's really important, specific to just the rhombus. All right, and now let's do the square. So the square is, to me, the easiest one, because if you had to guess, I think you'd probably guess it correctly. So basically the square is the rhombus and the rectangle put together. So if you notice, 4 congruent sides, that comes from, let me try to write it a little neater. That's the same thing as a rhombus, right? 4 right angles, that comes from a rectangle. Diagonals are congruent. Which one did that come from? That came from the rectangle. Diagonals are perpendicular. That came from the rhombus. And the diagonals bisect the angles. That came from the rhombus as well. So basically, if we think of a Venn diagram, this is something that, let me add a new page if I can do that. Okay, so if we think of a Venn diagram like this, this would be the square, this would be the rhombus, and this would be the rectangle. So basically, oh, and then parallelogram would be out here, because they're all parallelograms. That's why they're called special parallelograms, because they are parallelograms. They're just more specific. So the square shares everything of the rhombus and everything of the rectangle. Okay? To me, that picture kind of helps with some questions that you might be posed with later. All right, so I do not have to give you a single measurement, and you can know this angle is 45 degrees, because if it's a, excuse me, if we have a 90-degree box in the corner and the angles bisect each other, or the diagonals bisect the angle, then these are 45, 45, 45 all around. And then we're going to put in the right angle boxes here. And so like if you looked at a triangle, like this triangle right here, you would have a 45, 45, and a 90. And 45 plus 45 is 90, plus 90 is 180. Okay? All right, I'm going to zoom in a little bit for this one. Okay, so let me get a different color here. So it says A to B, no, A to E to B is 3x. Well, we got to put 3x equal to something. So 3x equals, well, what do we know about this angle here? We know that we can put the box. So that means it equals 90 degrees. And so x equals 30. And it just said solve for x, so we're done. All right. Let's erase this and do another one. So the next one says B to A to C. So this is 9x. Well, it's also 45 degrees because we just said up here, we don't have to know any of them. It's always going to be 45. So 9x equals 45. And so x equals 5. Okay. All right, let's look at another one. Okay, the next one says if AB is 2x plus 4 and CD is 3x minus 5, well, what do we know about a square? We know that all the sides are congruent, so we can put these equal to each other. 2x plus 4 equals 3x minus 5. So let's subtract and then add. Oops. So we're going to have 9 equals x. So that's x. Now it did say find BC. Now BC is over here. So we don't have anything to plug it into. So what do we plug it into? Well, the answer is doesn't matter. So you can plug it into either 2x plus 4 or the 3x minus 5. And you should get the same answer. Let's see if we do. So that's 18 plus 4, which is 22. And then that's 27 minus 5, which is 22. And the reason I plugged it into both is because they should be the same, right? And so then that means this would be 22, and so would this one. Okay? So then BC equals 22. I really should be boxing up my answers. Does that kind of make sense, you guys? Hope so. All right. And now let's look at the last one. D to A to C is Y, and B to A to C is 3x. Find x. All right, I really think that should be find x and y, but we'll do both. Okay, so y is going to automatically equal 45 degrees. We don't have to put anything equal to that. And then if B to A to C is 3x, we're going to put that equal to 45 as well. And so if we divide by 3x will equal 15. Okay, so pause the video if you need to. Go back, watch anything if something didn't make sense. But now we should have all of our parallelograms and special parallelograms. And so now I want you to try to finish this homework. Let's make it a little smaller so you can see. And so I want you to try 7 through 12. Send me those answers just like you've been doing. And then tomorrow, hopefully, I may or may not, depending on how you guys do, need to make a video. But tomorrow we're just going to practice kind of putting it all together for a day or two and maybe make it a little bit more challenging. But really the biggest thing, you guys, is you need to make sure you keep referencing your notes about the properties, those things we wrote down in the boxes, because those are going to be the most important things, okay, to help you answer these questions. All right, good luck. Send me a message if you need any help or if anything isn't clear.